Good afternoon and welcome to the New Space Economy Forum. And let me, as a first thing, starting to share a presentation that will help us today. So welcome to the session of New Space and our planet, climate, agriculture and food. As a first thing, I would like to introduce your two hosts of today. And first, I would like to introduce Sylvia Ciccarelli from the Italian Space Agency, from the industrial policy sector. And please, Sylvia, would you like to introduce yourself?
Yes, good afternoon, everybody. I'm really glad to be part of this panel today. Let me introduce myself very quickly. I am presently working at the Italian Space Agency in the International Affairs Directorate, and I'm in charge of the initiatives for the internationalization of the national space industry. I'm also Italian delegate at the ESA program board for human and robotic space exploration. And having an economic background, I'm also as a representative for the OECD Space Forum, as well as the ESA Space Economy Steering Committee. And that's all on my side.
Thank you, Sylvia. So my name is Giuseppe Borghi. I'm working with the European Space Agency since a bit more than 6 months. I'm the head of the ESA F-lab. I will tell you a bit more about the ESA F-lab later on. So let's enter in our session and let me give you a few information about the session. So our aim will be to discuss opportunities over the next 5 and 10 years in new space, climate, agriculture and food sector. So to not have a contingent look of today, but what we can do altogether in the next future. And to understand what new space can do for a better understanding of our planet, but also new space for a better planet with a flourishing society in a healthy planet. And to discuss this, we will have a representative from Climate Forecasting Center, from Agri-Food Market, new space solution and technology providers, and financial political agency bodies. So we have decided to divide these our invited speaker in 2 groups. One, the user and the political community representative will try to pose challenges to the solution, and agency, the solution provider and to the agency to get the best we can from the new space. And the debate will be around these 2 things. So we will be aiming to a very interactive session. We will have 8 invited speakers with question and answer at the end of each one of the speakers, also taking questions from the audience through the chat that you have on the platform. Let me give you some information about the structure of the session. So we are now in the welcome and introduction. I will pass over to Sylvia for introduce our speakers and our invited keynote speakers. And then I will give you some words about the topics of the session. After that, I will introduce you the first 4 speakers from ECMWF UK, from Geoville, Austria, from IBS Service, Italy, and from eGeos, Italy. And then I will hand over to Sylvia Ciccarelli for moderating the first panel that we will have today. After that, Sylvia, there will be a break, and then after that, Sylvia will introduce our keynote speaker, Dr. Sameh Wahba from the World Bank, and interact with him and discuss with him a bit. We will have another 5 minutes of break, and then the last 4 speakers, the first from Terranis in France, DFKI from Germany, Cosign from the Netherlands, and Planetech from Italy. And finally, I will hand over to Sylvia Ciccarelli for the second panel discussion. I will meet all together to have the session closer. We plan to finish between 18:30 and 18:35. So let me hand over now and ask Sylvia to introduce our invited speaker.
Yes, thank you, Giuseppe. I didn't interrupt you, but actually I can't see the presentation, so I don't know if you are sharing now, and that's that's me, that I'm not seeing the presentation, or is not working. In the meantime, I can go on. Okay, now it's working. Now I can see it. Okay, wonderful. So as Giuseppe mentioned, we have a quite well-articulated representation of speakers coming from different backgrounds. We have representatives from the institutional and research background. Our first speaker is Chiara Cagnazzo. She is a Sectoral Information System Manager of the Copernicus Climate Change Service from the European Center for Medium Range Weather Forecasts. ESMWF is both a research institute and an operational service producing global numerical weather predictions. Our second speaker is Andreas Walli. He is a commercial director of Geoville. Geoville is a global leader in satellite-based Earth observation with over 20 years of international experience. Through the Incubed initiative, the Geo4A subsidiary of Geoville spun out. This subsidiary develops information technology services for companies in the agribusiness based on satellite data and offering near real-time insights on parcels, crops, and regions to support decision-making in the agricultural area. Our third speaker is Donato Cillis. He is a scientific technical manager at IBF Servizi. IBF Servizi was born from ISMEA, an economic public entity in Italy, as well as from Bonifiche Ferraresi, the largest agriculture company in Italy. IBF was the first society that provides services of precision farming in Italy. So it's really relevant for our panel today. The next speaker is David Hello. He is a co-founder and CEO of Terranis. Terranis is an innovative small medium company specialized in the design, development, and sale of geoinformation services derived from satellite drone imageries in the fields of agriculture, environment, and land management. Terranis was founded in 2014 by Marc Tondriot and David Hello. The following speaker is Paolo Minciacchi. He is CEO and Managing Director of eGeos and head of Geo-information line of business of Telespazio. eGeos is an Asian telespazio company active in geo-information services and applications. eGeos is a global player whose applications cover, among the others, maritime surveillance, asset management, emergency, agriculture management, and many others. The following speaker is Andreas Dengel. He is a scientific director at DFKI. DFKI is the German Center for Artificial Intelligence. It was founded in 1988 as a non-profit public-private partnership. It's based on application-oriented basic research and develops products functions, prototypes, and patentable solutions in the field of information and communication technology. The following speaker is Marco Esposito. He is a remote sensing business unit manager at Cosign. Cosign is an innovative small-medium company combining physics and engineering to deliver better measurement solutions. Two examples of works with ESA are silicon pore optics, that is a novel technology developed by Cosign Measurement Systems for ESA X-ray Athena mission, and hyperspectral payload in the HyperScout mission. And we have then, last but not least, Giovanni Silos Labini, CEO of Planetech Italia. Planetech Italia is a medium company active in geoinformatics, space solutions, and earth science. Planetech provides solutions to exploit the value of geospatial data through all bases of a data lifecycle, from acquisition, storage, management, up to analysis and sharing. Planetech has experiences in environmental and land monitoring to open government and smart cities, agriculture and food production, defense and security, as well as satellite missions and space exploration. And I would like also to introduce our keynote speaker in the next slide. Giuseppe, please. The keynote speech will be given by Mr. Sameh Naguib Wahba. Sameh Wahba is the Global Director of the Global Practice for Urban Disaster Risk Management, Resilience and Land at the World Bank. World Bank doesn't need any presentation actually, but we can say that it's one of the world's largest international financial institutions with 189 member countries, staff from more than 170 countries all over the world, and offices in over 130 locations around the world. Its 5 institutions share a commitment to reduce poverty, increasing shared prosperity, and promoting sustainable development. Dr. Sameh Wahba is the Global Director for the World Bank Urban Disaster Risk Management, Resilience and Land Global Practice. This global practice covers also territorial development, geospatial and results-based financing issues, with a portfolio of close to $30 billion in commitments in investment projects, program for results and development policy lending, with headquarters in Washington, D.C. And this is the end of the presentation of all the speakers for our panel.
Thank you, Sylvia. Just confirming, Sylvia, you see my screen switching with the slide?
Yes, I do, and okay, I wish you an interesting and engaging session.
Thank you, Sylvia. So that's now my time to give to all of you some introductory words about the topics of today. So let's start talking about space. And space, as we know, is started as the industry after the Second World War, what we can call this the political space era, when there were the race between the supremacy between USA and Russia. That was the main motivation for the space activities, and that's lasted until the middle of the 70s. And after that, we had what we can call now the agency space era, where the planning and the activity in space were driven by the various national agencies, NASA, ESA, ISRO, CNES, and many others. But in the last period, in the last 10, 15 years, we have seen growing a new trend of commercial space that now we can call new space. And as a definition, we can use this one. So a global trend of emerging investment philosophy that is joined with key technological advances that has, from one side, reduced the barrier of entry for technology and for reaching the space, actually, so less cost to go in space. And on the other side, providing more data, more information, more reliable benefit from space. And this has enabled a private space industry that is largely, not only driven by commercial motivation. So it's a composition of cheaper access to space, richer and more affordable information and data and benefits we can get, but also a new entrepreneurial spirit. And as a classical example of new space, we can mention SpaceX, Elon Musk. So this company that together with others have developed a new launching system, in this case a reusable one, that has reduced by a factor of 5, 6 the cost to go in space. And SpaceX has also enabled, for example, USA, NASA to come back to human space flights to the International Space Station using an USA launcher, because in the last 9 years they had to use a Russian launcher, Soyuz. But the real motivation for Elon Musk and SpaceX is not to serve NASA, but actually to enter the space tourism era. Is where he wants to make the business and the money for these big activities. So the new space or the commercial space comes from the telecoms, so distribution of TV, distribution of data, and then navigation, so everything, all the application that has to do with GPS and Galileo services, and more recently, Earth observation with a new space asset, new satellite, constellation of small sats with different kind of sensor, but also new technology like artificial intelligence or higher level of computing. And that's also very true for the downstream. So all the activity that are done on Earth to exploit the image and data coming from space and delivering what are called actionable insight or information, not only images. And this, the Earth observation sector is actually the one that is going through the most deep transformation in business model right now. So we are talking about the commercial space, but we should not forget that the agency space is of course still existing and dominating in many parts of the space industry. And also this political space is still a key motivation for going into space. So commercial space, new space is only part of the bigger ecosystem. Let's talk about some numbers. So if we consider all the markets and business that have been enabled by space technology, also included, for example, distribution of goods or grocery or other things by a fleet of trucks that are enabled by GPS solution and GIS systems. So if you consider this market at a large, we have seen that in the last 11 years, there have been a big increase in private equity investment, up to a cumulative value of $160 billion. And this is touching about 1,200 companies worldwide. And you can see in the graph on the right, a quite steep increase in the last years. If you look at a breakdown of these by application, we see that position navigation and timing, so GPS and Galileo services, communication, and then launcher technology, and then satellites are the dominating element of this investment. Earth observation is still in its infancy, is just 1% of all of these investments. And if we look from regional point of view, we see USA dominating with 40% of the equity investment. Then we have China, Singapore, India, and Indonesia in the Far East. And Europe has a limited presence in these, so it is quite marginal. But if we consider what we can call the core space business, so something that are business more close to the technology, but still delivering services and value-added services and so on, we can see that this part of the core space business has seen in the last 20 years a number of $18 billion, so still a remarkable amount of investment, of private investment. And if we see again regionally, we see USA dominating, but here Europe has a 25% of share of this pie. This is to testify that Europe has nothing to regret from the technological point of view. There are no gaps. We dominate in several of the technology. Our big challenge is to translate these in business. That's something that USA and China and Far East are smarter than us, or more, let's say, lucky. But Europe is definitely catching up. And in particular, in the Earth observation market, we see several initiatives, both in new satellites, on thermal satellites, high-grade solution, or radar satellites, or even artificial intelligence-driven enabled satellite with, for example, distribution of cloud masking made directly on board of satellite, as the FSS-CAT FISAT-1 satellite recently launched by ESA and together with the Spain colleagues, But we should not again forget the downstream innovation, where all this information are translated into real actionable insight. And we can see that the European market of the data sales has in the last year grown at 9%, which is a big growth. You have to consider that space is growing at double of the global economy, about 7%, but this market is growing even faster. And if we look to the European market of Earth observation value-added services, this is growing at double digit, 10% of revenue, 11% of company, and 60% on number of employees. So Europe is really catching up. So what has everything this to do with climate, agriculture, and food? Well, climate is clear. All these should and can be used to produce what are undisputable facts about how is going with our climate, so-called climate change. And we should not give this for granted that is commonly agreed that there is this. And let me give you this, what was happening a couple of years ago, Emmanuel Macron at USA Congress, 2 years ago.
By polluting the oceans, not mitigating CO2 emissions, and destroying our biodiversity, we are killing our planet. Let us face it. There is no planet B.
So there is no planet B. And Macron in USA under the Trump era. So let me give you just one indicator. There are many, many indicators of this. Here you will see the trend of the CO2 concentration in the last 800,000 years. And you see a cyclical behavior here. But if you look on the right part of the graph, you see something very strange happening, going very, very high. And if we focus in these last years, so in the last 2,000 years, we see that in the last 40 years, something was happening. And you see a growth in the concentration that is unprecedented. But there are many, many other indicators that show this. So what space technology is doing? So agency space are building large constellations of Earth observation satellites to take the pulse of our planet. And ESA, together with a European community and EUMETSAT, has currently 16 satellites in operation and 40 satellites under development, plus another 13 under study. And just the Copernicus constellation of Sentinel satellites are delivering every day 250 terabytes of data to the society for scientific use or for commercial use, to make business. And these data are completely free to all of us. And they give information about chlorophyll concentration, sea level height, surface temperature, soil moisture, or carbon dioxide and nitrous oxide. And so what's the role here for the new space? But the new space should complement what the agency space is doing. So agency space are doing complex and long-term plan mission. The new space should be the agile entity of this, diversifying the offering, providing more and richer data, more services, complement, for example, Copernicus with high-grade solution, optical or SAR data that Copernicus doesn't deliver. So it means quickly react to the user demands and push the business and technology barrier. That's the role we see for the new space. Let me say a few words about my organization. So the F-lab is very active inside the new space, and our mission in Frascati, Italy, is to accelerate the future of the Earth observation through what we call transformation or disruptive innovation, exactly with the goal to strengthen the European world-leading competitiveness. And we are a kind of strange animal in ESA because we do from basic research, discovering idea in our ecosystem, in industry or research center, and then we select some of them, we test, develop, and when we find either in the ecosystem or internally very good idea, we invest. We are a kind of public investor with a fund of 100 million size that we are investing in 18 countries in Europe through the InCube program that you see here at the website on the left. We are currently, after a couple of years, 19 activities running with 35 million euro value in total, with co-funding that can go from 50% to 80%. And that's a big opportunity for our new space industry in Earth observation. So what we can do with everything like this? So we can use this data for forecasting, improving the accuracy of forecasting. And here we can see the forecasting accuracy for 3, 5, 7 days ahead accuracy from ECMWF. Or we can measure the soil moisture of our land in the Netherlands by Van der Sat, for example. Or look far away from Europe in, for example, North Vietnam, and see how is going the production of the rice in that region. Because, of course, this will have an impact into the rice market also in Europe. Or look into the land cover typology in Africa, far away, or look closer to us. So look in Belgium, for example, with this from Vito. So all these kind of topics will be touched in the session today. So thank you very much. That's the end of the introduction phase. So now we will have a first very small break, and then we'll introduce our first speakers. ECMWF, she will give us the first invited talk, and the title of this talk is The Sectoral Information System of Copernicus Climate Change Service, Valuable Information for Agriculture Sector. So Chiara, the floor is yours. Thank you very much.
Thank you. Thank you, Giuseppe. I'm going to share my screen, and please shut in case you cannot see my screen.
Okay, so, we see you very well, and we see the screen.
Thank you. So, good morning, everybody, and thank you for this nice introduction. So I'm trying to go now to give you a brief overview of the sectoral information system component of the Copernicus Climate Change Service, this C3S. And yes, as Giuseppe was introducing, I will focus mostly on the information that is relevant to the agriculture sector. And I will try to take a kind of a climate perspective. So there are many studies that look at connections between agriculture and climate change, and we know that agriculture is affected by climate change. And if you look at the different variables, precipitation is just one variable, one key variable, of course, but it is not the only one. But it is a quite relevant variable in the sense that the precipitation variability plays a significant role in the agriculture sector. And if we look at what the crop climate model projections give us as an indication, is that we may expect a reduction in the productivity of agriculture of about 0.5% if we reduce the precipitation of about 1 percentage point. But of course, this has quite a large variability. So the figure that you see now shows in colors a projected increase in blue or a decrease in red of the precipitation of the rainfall. And this is based on climate model projections on future scenarios run with climate models. And those changes, the figures, shows where and when those changes will appear as a clear signal that emerges from the background variability. And in the two maps are shown two different scenarios. On the top, it's a scenario with a very ambitious mitigation policy implemented, whereas in the bottom panel, you see an ambitious mitigation policy implemented. So the main message is that the Mediterranean area, you may see in red, and the Mediterranean-like climate areas are the most affected by a reduction in precipitation. And this is expected to happen quite soon in the next decades. But of course, the picture is more complex than this, because the global food supply is of course vulnerable, because let's say a large fraction of the global food production is concentrated in selected regions of the world, because climate change is only one of the components, one of the many pressures on the agriculture system, because faced with a growing global demand and competition for resources, the food production and consumption need to be seen in a kind of a broader context, so linking agriculture, energy, and food security. And of course, links to the water availability is quite important. So in a nutshell, we may say that on the one side, agriculture is one of the most climate-dependent sector, But of course, we know also that before reaching our plates, the food is produced, the food is stored, is processed, is packaged, is transported, and this at every stage somehow release greenhouse gases into the atmosphere. And farming, in particular, releases a significant amount of methane and nitrous oxide that are two very powerful greenhouse gases. So the second key message is that, let's say on the other side, the agriculture contributes significantly to climate change. So the question is now, what could we do and how could we adapt the food production system to cope with climate change? This slide now is showing the different sustainable development goals, 17 sustainable development goals that have been defined by the UN CCC agenda. And this was adopted in 2015 by the different governments. And the agenda is there really with a commitment to eradicate poverty and to achieve sustainable development by 2030 at a global level, and ensuring that no one is left behind. So in blue, we see the connections between these sustainable development goals and the agriculture, food and agriculture sectors. So if we want to address those goals, which are the ingredients that we need? So the first key ingredient is, of course, has to deal with data. And here, data from space. So here I'm showing the slide that highlights the Copernicus European program that Giuseppe was also mentioning a few minutes ago. This is a very big program for Earth observation and, of course, to monitor the Earth and the environment. And we have different data from the Sentinel satellites that are becoming available and will continue to become available in the next decades. And as Giuseppe was saying, it is very important the data are free, they are open access, and they are accompanied by quality information. But together with the data, the program arrives or articulates into different services. And here we have 6 different services. And the Copernicus Climate Change Service, the C3S, that was in my first slide, is one of the 2 services that the European Centre for Medium Range Weather Forecast is managing for the EU. Okay, so C3S is an operational program. It provides free and open access to climate data at different timescales. And this is highlighted in the left panel of this infogram. It gives access to the data in an authoritative and standardized way. This is quite important, but also in a transparent way. And together with data, we give access to software tools. And so the purpose is really to enable climate change mitigation and adaptation strategies by users that are policymakers and their businesses, as shown on the right-hand side of this slide. But if we look at the agriculture sector specifically, we offer different information, different products that are of different nature and different typology. And here I'm going to focus just on one specific aspect and on one specific service, that is the Global Agriculture Service, and I will show just a couple of examples. So first of all, so this service gives information both at the local scale and at the global scale. And at both scales are important because, of course, on the one side, we have that nationally consumed crop production varies of the order of 25% at the local scale, at the national scale, and globally at less than 3%. So this means that we need to support local and national decision makers and support an international trade, for example. So the service as it is offers information for different actors. So on the one side, it offers information to the research community by providing, for example, a global coverage, data sets with no gaps, and easy of use in the sense that following specific scientific standards. On the other side, it gives information to the agribusiness sector, because for the business, it is quite important to have information that it is near real time, so timeliness information. It gives information that is quite at a high resolution in space and in time, and it also offers an interface with the users that is user-friendly. But it also gives information to the policymakers, by ensuring continuity with respect to the policy cycle, by focusing on quality assurance product, and by also ensuring that any downstream application that is already ongoing is, of course, kept and maintained. So Okay, so this service is focusing on different aspects, and one aspect is giving access to data and giving access to specific data products. In this case, we have, let's say, the first typology of data are long-term data that are really developed and focused to permit crop models to easily make those data, use those data as an input. It also includes indicators that are more water-based indicators, such as soil moisture, groundwater recharge, or reservoir inflow. The third typology of data that is produced within this sector are agroclimatic indicators, and those are both generic and crop-specific, and this may include, for expert, cold and heat stress days or growing degree days. And finally, gives information also to what we call a climate-enhanced Earth observation-based indicators. So in this case, those are crop-specific things like the dry matter productivity or the evapotranspiration. And let's say these indicators are nicely given and also aggregated to crop-specific, like phenological calendars and growing areas. Now go to make you just an example and to showcase how it is possible to make use of those information and of this data set in specific cases. And the first case that I'm going to show you is the soybean case. So the soybean is grown all over the world, and it is quite important because it gives a source of high quality protein, but it also is used for feeding and for producing biofuel. So which are the users that we address, and which are the users that need this information and data? So we have users like commodity traders, we have users that is food and feed processing industries or food securities, and their needs are, of course, focusing on specific crop stages information. So this is needed because they need to plan logistics, they need to plan trading, but they also need to have information about early warning on food security. And what it is quite nice in this data set, maybe this is more for experts, is that it is not just giving the total biomass. This is a typical information that is found also in other data sets, but it gives info into the edible parts. And see, this, as I was saying, is a climate-enhanced Earth observation data. In practice, it is produced by making use of both satellite observation from the Copernicus, but also to a reanalysis of climate. And by putting together this information, it is possible to derive variables such as the crop productivity or the harvest index. And the time coverage is until the end of 1999 to present. So the users need to have this information, especially because they need to plan, and the farm logistics is quite important. We're like with respect to where, to when, and to how much of crop to expect. This is just a snapshot of this product. It's one of the many products that is available. So this map is showing a variable that is named a development stage for the specific crop. And when it is quite reddish, it means that it is the crop is quite mature. Whereas where it is bluish, it is not. Or another variable that is extracted from this data set is related instead to the grain yield. So this information may help to understand how much to expect. And if you see this very small diagram or time series, it's just showing for a time series the above normal production, for example, for year 2017 in that specific area for that specific crop. But we have also other users that are interested in this kind of information, but derive it in a different way, because these kind of users are now more interested, for example, in how much water is needed. And okay, so in this case, we are talking about a different typology of users. So, for example, water managers or farmers who are more interested in knowing if and where it is needed to use water. And I will go fast, and this is just a snapshot of another variable that is called the actual evapotranspiration, but somehow putting together variables, it is important that it is possible to understand where there is the need of the water. So this was just a very quick example of the use of one of those products. The second quick example I wanted to show you is instead related to another project that is, again, another collaboration that we have, in this case with the Space Climate Observatory and with the CNES. So this is a project that focuses instead on looking at the extremes in the hydrometeorological events in a specific region that is now in the south of France, that is the Aude region. And as you may see on the left-hand side, there are some satellite images, and one aspect of this nice project is also looking at the vineyard. So the plot or the figures on the left-hand side are showing, for example, flooded areas in vineyards. On the right-hand side, it is highlighted that this specific activity instead looks at extremes of hydrometeor events and try to understand and to define those extremes for the past data. So you need a very long climate data record, as well as what to expect for the future. I will, yes, okay, maybe I will conclude, and I will just mention this last demo case, but I'm not going to detail it because the time is finished. So this is instead a quite completely different use case, and this makes use of a completely different data set. And I mention it here because on the one side, it demonstrates that it is possible to build really specific information that are relevant even at the local scale, for example, for specific farmers, but also to highlight that somehow we also push and support the development of applications that are downstream of us. So, for example, applications that may be developed by the private sector and by using completely free data, completely free tools, and then that of course, make their own market on that and sell the information to the customers. Okay, so my last slide is quite busy, but I will just focus on 2 points about the service evolution that are shown on the top of this slide. So the first point is that we will continue, of course, to expand the data portfolio, and this is based on the new satellite observations, but also on new climate reanalysis that I've not mentioned so far much, on climate predictions, on climate projections, and on past historical data. And the second point is that we are planning to evolve our applications, our tools, our data, so the entire system, big data and tools, to become fit for purpose for the artificial intelligence applications. And of course, in the lower part of the diagrams, just highlighting that we are continuing our role of monitoring climate and also working on some climate attribution service. And I thank you very much for your attention.
Thank you, Chiara. Very, very interesting. And I see there are many links on what our next invited speaker will say about, for example, water stress and so on. So one quick question. As you said, thank you very much. You have been so great to stay in your time. We don't have much time, but I want to ask you a question. What do you think will be the role for new space for the mission of Copernicus climate change services? What do you think will be the real burning needs in 10 years from now? What you would like to get from that?
Yeah, okay. I think that on the one side, we have kind of several key variables that we are just only starting to observe, like, for example, permafrost, salinity, root sea level, soil moisture, river discharge. And so we need to invest on the one side on the new technologies to be able to have and to obtain those kind of observations. Let's say that on the other side, we need also to focus on quite a lot of post-processing with respect to what it is already available, because, for example, today we give access to just a limited amount of essential climate variables that are very important. And we have now the technology that permits us to give information also with respect to new essential climate variable and produce new climate data records, for example. But also we have to work a lot on the interoperability of the data and the standardization. This is a very important issue because, as you have seen in this example of the crop, so in this example of the crop, for the agriculture, so we really have to put together Earth observation data and modeling, and this need absolutely to work with standards to make the data easy to interoperate.
Thank you very much, Chiara. Silvia, do you think we have good questions to put, or we go to the other
We are a bit out of time, but I have a quick question from the audience. Maybe we can try to answer quickly. The question is, where you see the highest impact of high priority mission from Copernicus? So which is the highest priority from Copernicus?
Oh, I think there are many different priorities. I'm not sure. It's a very complex question. Maybe let's say that on the one side we have the missions, of course, and I was saying, for example, observing new variables is absolutely crucial and continue to expand the climate data record. But on the other side, I think we need to really work a lot on how to transform and to extract the information that is inherent into those climate data into a usable knowledge for the users. For me, we really need to stress a lot on the gaps between the data, the number that comes from the different and the new climate observation, until the fact that we can really transform it into a piece of making a new decision. So a piece of information that helps a user to make a new decision. And there are many examples that, of course, if then your user interested, I may share with you.
Okay, thank you very much, Chiara. Really interesting. And let's now have a very small break, and then we'll introduce our second invited speaker. Thank you very much. Welcome back. So we are here back now with Sylvia again, and with our next invited speaker, Andreas Walli from Geoville. Hi, Andreas.
Hello, everybody.
Okay, so as we said, Geoville is a company that is in Austria, has worked very recently with us at the F-lab, quite successful, I would say. So Andreas will give us a talk. The title is New Space Opening and New Opportunities in the Agri-Food Industry. So Andreas, the floor is yours. You can start to share your presentation.
Thank you very much, Giuseppe. So my name is Andreas Walli. I'm the Commercial Director of the Geoville Information Systems Group. I'm in the space application sector since 23 years. And in the context of the new space economy, I would like to present today to you a very successful new blueprint for ICT-based business model that helps industrial operators of the agri-food industry to use Earth observation information solutions for the value chain. And I'd like to add that the work that I present to you today would have not been possible without the support of the F-lab's experts and also the flexibility of the InCube program. Instead of going through slides, we prepared a short movie for you. It's about 2 minutes that summarizes well what we have achieved. So please lean back, watch and listen, and I will be back after the movie to provide a little bit more information and answer your questions.
The agro-food sector is facing increasing problems and challenges to be able to satisfy the growing global food demand. Climate change and global warming are increasingly evident and have direct impacts on cultivation success and agricultural production. These factors demand an improved efficiency from farm to fork. Unfortunately, the pace of innovation in the agro-food industry has not kept up. One of the core challenges is the lack of homogeneous information about fields and plants. In order to better coordinate supply, logistics, processing steps, and sales, what if the agro-food value chain operators would be able to integrate status information about environmental conditions during a growing season, the expected vitality and quality of the plants, the actual crop-specific growing acreages? That's why we have launched EO plugin, providing an end-to-end system that allows access continuous and specialized information streams, allowing to increase coordination capacity, leading to a more efficient production, resulting in better management processes, less crop loss, better sales strategies and contracts. As our initial market, we have identified the potato industry in the Netherlands, and to guarantee market access, Geo4A was founded by Geoville in 2019. Geo4A has already generated a trusted customer base. Our current services include field and parcel measurements, near real-time crop monitoring, crop analytics, forecast yield and quality. Now, you might ask yourself, why not use this for different sectors or different countries? Well, that's exactly the plan. The applicability to different sectors and different countries has always been our strategy. The development of EO plugin is driven by true leading senior industry experts, from agrofood, earth observation, data analysts, artificial intelligence, IT and business development. Sure that this combination and development requires crucial soft skills like teamwork, communication, responsibility, and problem solving. It's all about agriculture.
It's 4 o'clock.
So, you have heard that Geo4A is a blueprint with this IT system. Started this business last year, basically. And we are quite happy to report that already this year we have attained quite substantial revenue. It's actually this good that just with this one sector focus on the potato industry, we will reach a break-even point of the investments basically by early 2022. And just by leaving it this way, we envisage a yearly turnover of about 7 to 8 million euros with services alone by 25. And what we are currently working on, as you heard, is applying the same blueprint to other commodities sectors like carrots, like wheats, etc. And we were quite happy that we could implement it in this fast way through the InQ program. So with this, thank you very much for listening, and please, if you have any questions, I'm ready to answer them.
Thank you, Andreas. Very interesting, and especially the fact that you are going to reach the break-even quite soon, I would say. That's very impressive. Maybe, given your experience, if you can tell us, okay, if we consider the full agri-food market, we know, of course, that not all the operators in this market are using this kind of services. Can you give us an idea of how many of these operators are right now using currently, and what you think will happen in 10 years from now? So how big will be the market when hopefully it will become a stable market, not a growing market?
Yes. So in our experience so far, we were very surprised, even with the very big players, meaning the companies that are well known globally, how less they use Earth observation, and very, very few have started to really onboard them and use them for the operational services. There's still a lot of trust to be established by these operators. Earth observation still has to prove the value for the money, basically. But often what we see, and that's why we launched EO plugin, it's really the challenges of how to get and how to use the data. And so just by having now this system in place, it's quite incredible how fast, without proactive marketing, just through word of mouth, basically, in the industry, for what kind of companies are approaching us, like companies that we thought that we would never have a chance as a small company from Austria to get into. Like, for example, McCain, one of the biggest fry producers in the world, just contacted us 2 weeks ago, and we had already 3 sessions with their technical teams. And we realized that they basically, I mean, there were a couple of feasibility and demonstration studies, so to say, in the last years that they participated in, but they haven't really in the last years even thought about including into their operations. And now with a lot of new, not only reporting applications, especially through Europe, they really need basically solutions that provide them with globally with intelligence capacity, and the space industry is definitely the one who can provide it.
Thank you very much. And another question that I have is related to the funding source. Of course, we have said that Geoville was so good to find an investment through ESA, but in general, funding of this kind of initiative is a challenge. So what do you think is the perspective from companies like yours that are acting in new space to get source of funding in Europe especially? Because we have seen that something very big is happening in USA and probably in Europe is not so easy. So what's your perception about this?
Yeah, it's a very tricky and it's also a difficult question. Our perception so far is that even with small companies or large ones, doesn't matter. The longer you're in the business, the more credible you are. Like Geoville is in the business since 22 years now. It's much harder to get especially private equity funds or investors on board. They're looking for new ideas, young generation that can really follow up on ideas. And it's what we see is particularly for the startups that come maybe with quite groundbreaking new ideas and have also maybe disruptive technologies, that they are the ones who are successful to attract private investors. But it's particularly difficult for basically the majority of the industry that has been built up to date, also with the help of the European Space Agency. And that's what we see as quite a big problem for us. We are confident that this problem has been already identified by the European Commission. And I personally, I've just gotten a very interesting information for new incentives by the Commission to help that, especially for high-tech, high-risk activities of the European IT industry, and the space industry is definitely related to that. So I'm really looking forward that incentives will happen to further be able to implement new ideas that experts really have been developing through the years. Yeah.
Thank you, Andreas. Thank you, very interesting. And I hope to see you soon again in new events. So we will move now. Thank you very much, Andreas. We'll move now to our first speaker after a few seconds of break. Thank you. See you soon.
Everybody. First of all, I bring greeting regards from Bonifiche Ferraresi CEO, Dr. Federico Vecchioni, and it's a pleasure for me to show how Earth observation is used as a support system, decision support system in agriculture from my companies. First of all, nowadays, Earth observation offers a wide range of solutions to agricultural sector, ranging from different kind of data source and different resolution in terms of spatial resolution, temporal resolution, and it leads to a different activity that can be performed through opportunity processed analysis, ranging from crop type detection on the evaluation of accuracy of managing operation activity over the field, and finally to detect in order to detect the crop status, nutritional or water availability for the crop. And in this regard, Earth observation becomes one of the ring of value chain that Bonifiche Ferraresi brought to the market, that thanks to their managed companies, offers to the market a manufactured agro-industrial product fully tracked, ranging from the breeding and the definition of new seed variety, to the retailer with a product named Le Stagioni d'Italia, that is the brand of the company. And in this regard, the company who got the know-how in managing and analyzing this geospatial information is EBF Servizi. EBF Servizi is a company that provides for services in precision agriculture to the national and international agricultural sector. And EBF Servizi is composed by three main pillars. The first one, the original one, is the know-how got in agricultural sector, thanks to the Bonifiche Ferraresi's farms. The institutional vision and the scientific committee is a proof, a warranty of the ability of our services and the technology. One of them, especially in terms of Earth observation data providing, is eGeos, which is a global player in data and services provider. Our activity is related in managing all the, try to manage and support farmers to all the managing activity for the whole crop cycle assessment. And also after that, regarding the agro-industrial sector. But now let's see and let's do some specific example regarding all the and how is interpreted our Earth observation analysis, data analysis. The key words is data fusion. As you can see in the slide, the data, Earth observation data, is integrated in a process, a workflow that use other information layer. For example, weather data, soil data, proximal sensor, in situ observation, enabling to analyze all the perspective of a cropping system. All of these data are integrated in a web platform that is useful to share the information, the output layer, at two different scales, from regional scale and to farm scale level. All the information layer are shared to the farmer or to the final user that carry out all the operation activity, and it gives some benefits to the final retailer, ranging from the farmer to the agro-industrial sector. It leads, of course, to a best managing operation in terms of agronomic benefits, economic benefits, and environmental sustainability managing of the cropping system. But now, some example regarding the activity that we perform with the remote sensing. It can be used as a simple remotely crop cycle monitoring. We can provide this image to a farmer or to a technician that can interpret the information related to the field. Otherwise, we can use at a district scale, regional scale level, this information integrated with some other data, for example, weather data, in order to detect the crop, the different kind of crop grown on a specific surface, or it could be used from policymaker in order to verify if some area are cultivated in the proper way, especially if there is a premium, a benefits related to this kind of cropping system. That, besides considering the farm scale level, Earth observation can be used in order to analyze in-field variability, and thanks to a multi-temporal analysis of vegetation index of the crop cultivated over the year in the same surface, we can define some areas with the same attitude. So over there, we go to collect data, for instance, soil especially, in order to characterize this variability, and it is the first layer enabling to manage soil variability and the cropping system of the next year. Now, let's finish the data collection. It's time to define the managing strategy. So in this regard, the first step is to define the crop suitability of a reference crop that is useful to define the stability of production and be able to have a prediction of the yield for a reference crop. This is the first information. This is an output that becomes an input for the agronomical model, enabled to define the best amount of seed rate to apply for each zone of the field. On the other hand, another interesting, one of the most important managing operation that is to be applied to the cropping system is fertilization. In this regard, our model integrate weather crop requirement, weather data that allow us to simulate the phenology, the crop stage of a reference crop, and integrating this information with Earth observation data, especially biophysical parameters, for example, chlorophyll content, and as you can see in the presentation, or lie or crop lie, we can define the best. We can optimize a starting fertilizer rate in order to understand and to carry out managing operation, considering the interaction between soil, crop, and weather over the crop cycle. On the other hand, irrigation is one of the most important activity affecting cropping system, especially in some area, and Italy is of course one of them. It is recognized that we use two different approach to define the best irrigation plan. The first one is water balance, and nowadays it's recognized that Earth observation could give good information in correcting the KC of the crop in order to define the crop evapotranspiration. On the other hand, is it useful to define the most representative area within the field where to install proximal sensing? As you can see in the picture, there is a soil moisture sensor and a weather station in the field in order to optimize irrigation plan, especially in horticulture crop. But as I told you at the beginning of the presentation, there are a lot of data sources in Earth observation. We are involved in several projects that aims to define soil moisture using SAR data or thermal or infrared data deriving from satellite. Finally, this is the last step. The integration, the synergy between remote sensing and proximal sensing technology is expressed in this slide. That we mean when we are not a good spatial resolution to support farmer in defining the best managing solution for a reference crop, we use remote sensing to define some area, some representative area where we defined a bias, an anomaly. And then we perform a data collection in order to increase this incisiveness. Or on the other hand, we can install some proximal sensor in order to get a more resolution, enabling us to support the farmer. Finally, I would like to show this slide because the last mile nowadays it could be to overlap, to define the good strength and the overlapping between three different areas. The user needed, because nowadays especially the farmer does not understand the advantages related to Earth observation. The technology, so develop some technology that could gain the user needs. And research and development, I inserted research and development because probably nowadays we need at farm scale level, let me know, absolute value, not relative value. For example, I have a vegetation index and it is a number. Maybe have an absolute value that is more useful to convert this information to a managing operation. And that's all.
Okay, thank you very much, Donato. Thanks, very interesting. I'm sorry, but I think we are running a bit late. I don't know, Sylvia, if there is any question we should push from the audience, but I would move to the next speaker. Yeah. Thank you very much. It was really nice to. Thank you.
Thank you.
Thank you. Geoinformation line of business Telespazio. Hi, Paolo. How are you?
Good evening. Very fine, and thank you for this invitation.
Thanks for your time, and I would say let's go straight. The floor is yours.
Okay, thank you. I will try to be effective in the presentation. It's also very interesting to start this presentation soon after my colleagues of Geoville and IBF. We are also shareholders of IBF, and we are working together with them in the field of precision farming. Just some context information. Let's say in the frame of the geoinformation line of business of Telespazio, we are around 600 people, half of them in Italy, but let's say the other part in Germany and distributed worldwide in our subsidiaries. And let's say in this frame, there is eGeos, that is, let's say, the largest geoinformation company in Italy. And is a company that is formed, it's a joint venture together with the Italian Space Agency and Telespazio. And as reported before, we are also shareholders of IBF Services and also of one very important innovative company that is called EarthLab, that is based in Luxembourg and is really working on the innovation field in the Earth observation business. as I will explain shortly. So let's go to see our geographical footprint. We are, let's say, more or less everywhere. In some countries, mainly Europe, we have our direct subsidiaries. So we have companies located there that are working also in the geoinformation business. The same in South America, so in Brazil and in Argentina. And we are also in the USA, Far East and Oceania, Australia, with, let's say, some important partnership also with the Leonardo Group. So we are globally, let's say, looking to the geoinformation market, and in this way we can also see the trend of the market and the trend of the technology worldwide. From this point of view, we are in all the fields of the value chain of this kind of activity, starting from data operation and also station operation, up to the, let's say, the last part of the value chain. And the last part of the value chain, in my point of view, is representing, let's say, the real new trend. So the fields, the domain of the artificial intelligence and the domain of the big data analysis. And then providing all the other steps, so starting from imagery and then arriving to analytics, we are able to provide consultancy mainly exactly in the international funding institutions. So also in the area where sustainability starts to become really a very important and hot topic. If we enter, let's say, in the domain of eGeos, let's say what I want this slide. The only motivation why is here, because you can see geoinformation services, artificial intelligence based on multi-sensor and geospatial data combined with Internet of Things and big data. So why I included this slide and this concept is because this is the trend. I think that this was also in all the presentation of my previous colleagues, is the trend. The trend is multi-platform, multi-sensor, big amount of things, big amount of information, not only coming from satellites, but also coming from other interesting platforms. For example, we are also in the business of drones, but also coming from social media. The trend is that all this amount of information can be, let's say, in a way or the other, mixed up and then analyzed with technical algorithms of artificial intelligence, and also, let's say, mathematical algorithms. In this way, the final results of this analysis, I would say, is the information that we have to provide to the stakeholders. And these stakeholders, at the end, are the ones that are building the market from the commercial point of view and at the institutional point of view. To address this kind of evolution, technological evolution, what we have done has been to see to those verticals that are now mainly representing the trend at institutional level and commercial level, and develop specific application platform. And this application platform, in a way, are also related to what we are discussing today. You can see that we have a platform called AgriGeo for the agriculture domain. We have a platform based for the so-called C&C that is dedicated to the maritime surveillance, both from the environmental point of view, but also from the point of view of let's say, analyzing illegal movement in the sea. And then we have also another platform that is dedicated to the emergency management, strictly correlated to the changes and problems that now we have for the climate change. All these things are mixed up in, let's say, the so-called platform of platform, CLEOS, that is a marketplace where the user can find the solution, find the data, and develop their own application. So the trend is moving from data to big data analytics, and the way to address it that we have chosen is a platform domain mixed up with artificial intelligence and mixed up with a digital marketplace. let's say, which is the role of geoinformation innovation in the frame of sustainability? It's clear that currently we are here also to discuss this point. The climate change is really one of the most difficult global challenge. And for sure, the geoinformation, as also discussed by my colleagues, has an important role in this area. Let's say, and this important role, it's strictly related to the capability to give to the final, let's say, decision board to give the right information. It's clear that here you see some elements and some examples. You start from the climate change. You can also look to which is the contribution to the climate change based on the effect of deforestation, and then let's say the same effect and the same technology to be used in the frame of agriculture. For sure, I'm not going to repeat the concept already expressed by my previous colleagues, but it's clear that if we enter in the domain of sustainability and we look specifically to some of the goals of the 2030 agenda of the United Nations, you can see that most of this point can be addressed, analyzed, and supported by the geoinformation application. Here you see some examples, but either in the agriculture, as we already discussed, in the cadastre, in the urban environment, for sure in the quality of the environment, the degradation, also in the frame of potential, let's say, ground motion problems, and for sure in the maritime domain. Basically, if we see, this is an analysis of the trend of which are, let's say, which have been the natural disasters in the last decades. You see that the flood, the storms, and so on, that are really and strictly correlated to the problem of the climate changes are increasing a lot. 44% for the flood and 28% for the storm, and more or less also for the other categories. So it seems that it's clear that this is the challenge that we have in front of us, and is also the challenge that we have to resolve, because at the end, the role of technology and the role of geoinformation, at the end, in my opinion, is that we have to find a way to help the society, for sure, to grow economically, but in the same time also to have a better life. So to have a sort of, let's say, a new space economy that will have the final goal to be the space for citizens. So the possibility to use the new technology to help society and to make our life better. In this frame, let's say, it's clear that when we have a situation like the one that I have described, so the situation where the risks are increasing due to the climate changes, we can also support the analysis and the prediction of which are the areas of risk. Here you see only a couple of examples. One is related to the possibility to understand which is, let's say, the problem in the stability, infrastructure or also ground. And so stability that can be, let's say, if you can predict, you can avoid the disaster. And then this is on the right, you will find another examples that is strictly related to one of the major risks due to the climate changes, that is the flood. So using and mixing different technology, different algorithms and artificial intelligence, you can model, let's say, the ground and to understand in advance which can be the risk of flood in certain area. If we still stay in the climate section, I don't want to enter in the details, but at the end, what we see that also there, if you can start from, let's say, market, or in case of institution, requirement analysis, user requirement analysis, but at the end, the solution is always going through modeling, artificial intelligence, platform, and training. So this is the trend. And the same if you enter in the so-called digital twin earth precursor. What is, let's say, what is behind this? Is that if we are able to build a real model, no, that is, it will require a huge amount of data. It's already, let's say, one of the most important objectives of the future. Really huge amount of data, but a real model of our Earth. Then we can use, I don't know why this is moving the presentation, but then we can use our technology to make the emulation of the behavior of our Earth with respect to, let's say, forecasting, and also with respect to climate phenomena, and then to give to the decision maker information to understand the impact at regional level. It's clear that this is something that currently we are still in the precursor area, but in the future will be always more and more a reality. I will skip this slide, but let's say another aspect that we can for sure understand, it's to see the trend of what is going on in the frame of forest. Because we know that it's one of the way to try to keep our life better and to reduce the amount of CO2. It's clear that this can be with classical technologies, but at the end, also in this frame, the final results will be a platform, data, artificial intelligence, algorithms, and then the possibility to access via a simple web interface to this kind of product. It's clear that the most, let's say, the most critical part is the modeling, but at the end, these instruments can be used to show how deforestation is progressing, and then to intervene in different areas of the world. In this case, we are talking about models that we have developed together with our company GAF in Africa. We can intervene and try to remove, let's say, this kind of problems and try to control and to improve deforestation, not the deforestation. Finally, let's say we go to the agriculture domain. Now I will concentrate, let's say, on some aspect, because it's the precision farming is a reality for us. On some aspect, no, there are some action that we have to implement in the future. Most of them are linked to, let's say, the control of pesticides, the evaluation of nutrients, and so on. And let's say that's why at the Europe level, some key drivers, key research areas have been identified. And one of these key drivers is the Earth observation space contents. Because from Earth observation, most of these, let's say, problems, or most of this criticality can be checked, but not only, let's say, in terms of providing the possibility to reduce let's say, the usage of water or to optimize the production, but also to understand if there are elements that can, let's say, jeopardize our health. In this frame, we are working also with the colleagues of IBF in some of this project, but in this frame, let's say, I can report a couple of interesting experience that we have implemented as a preliminary project. We were working on it. One is the so-called GeoAdvantis. Is the possibility to use the technology of drones, so small drones, to look in the fields and to understand if there are, let's say, plants that can be like a poison for the people. And this has to be done really locally with specific algorithms that can understand if that kind of grass is one that can create problem to the health. And the other examples that you are developing in this moment, in the future, for the future project for the European Commission level, is other project based on drones using specific sensor that could understand if in the water there is a certain level of nutrients that is exceeding the low level and then to intervene them. So my final remark is the following. Let's say it's the technology is there and is evolving in the frame of the real analysis of this huge amount of data with the new technology, with cloud computing, with high power computing, with artificial intelligence, with digital marketplace. But the final goal of the downstream application of the Earth observation is for us, is for make our life better. That's why I think that at Europe level, we should push a lot to have at the end a real market uptake of the downstream services, because it will improve a lot, let's say, our life.
Thank you, Paolo. Thank you for your talk, really full of idea we should discuss. We probably have time for one question. Sylvia, do you have one question for Paolo?
Yes, I have a question from the audience. They are asking, how do you deal with the different quality of the data sources? It can be assumed that data from drones have a different maturity than other products. So how do you deal with these different sources of data?
We have developed, this is an interesting question, thank you. We have developed a set of specific application for the drones, and also, let's say, a new platform that is called T-Drones. With this platform, let's say, we have the capability of doing different things. First of all, one of the difference between the satellites and the drones is the mission management at the end. Because the drones, if you start to talk also with drones that can be a little bit more weight, needs, let's say, very accurate mission management. And then if you want to obtain results, you should have also the capability to control a fleet of drones and to plan well in advance the path that we have to do. Then, for sure, the drones have, let's say, observation capability, different data, but we have solved this issue inside our platform, because our goal is already in place to integrate the product produced by drones, and can be also different kind of products, by the way, in our vertical. For sure, the resolution is different, the way of taking the images is different, but we have already solved it, and the drones are part of our current offer. And we want to export it as much as possible worldwide. One, let's say, final consideration from my side. When I say that the downstream application can improve our life, it means also that I would like to see investment from this point of view. And as we saw in the presentation of Giuseppe at the beginning, from this, let's say, from certain aspect in the downstream market, I see that Europe should improve a little bit the coordination between the different stakeholders in terms of having, let's say, the so-called critical mass in the request. In this way, then we can guarantee an organic growth of all the companies that are working in the sectors, and let's say also the possibility of the private sectors to make more investment, to generate more employment, and then to be more resilient.
Thank you, Paolo. So we move now to the panel discussion session. So we say thank you again to Paolo, and after a few seconds of break, we will move to the panel session.